Okay, so pure 1 Jan 2021. This is exciting. Okay, let's see how quick we can get through this paper then. So I think there's only 9 questions, which is nice. Yeah, 9 questions. So here we go. Right, question 1. A curve has the equation y equals 2x cubed minus 5x squared minus 3 over 2x plus 7. Find in its simplest form the differential. So step 1, index form, okay? So part A, we're going to rewrite this. So y equals 2x cubed minus 5x squared minus 3 over 2x to the negative 1 plus 7. Now that I have this in index form, what I'm going to do is I am going to differentiate. So we're going to bring the power down and then take away 1 from the power. So 2 times 3 is 6x squared. Minus 5 times 2 is minus 10x. Minus 1 times minus 3 over 2 is plus 3 over 2. X, take away 1 from the power, negative 2, and 7 differentiated is 0. So there we go, nice, easy, 3 marks. Part B. The point P lies on the curve and has x coordinate half. Find an equation of the normal to the curve at P. Write in your answers in the form ax plus by plus c equals 0. Okay, so first of all, if we know this is the x coordinate half, we can find the gradient of the tangent by substituting a half into our gradient function. So the gradient of the tangent is going to be 6 lots of a half squared minus 10 lots of a half plus 3 over 2 lots of a half to the negative 2. Brilliant, which equals 5 over 2. So that must mean the gradient of the normal is the negative reciprocal, which is negative 2 over 5. Okay, so for equation of a straight line, I have y equals mx plus c. I need an x coordinate, a y coordinate, a gradient. I've got a gradient, I've got an x. How am I going to find my y? I'm going to substitute a half back into this original equation. So I'm going to get y equals 2 lots of a half cubed minus 5 lots of a half squared minus 3 over 2 lots of a half plus 7. That gives our y coordinate. Okay, so my y coordinate is 3. So now I'm going to have 3 equals minus 2 over 5 lots of a half plus c. So we're going to have 3 plus 2 over 5 times a half. Is 16 over 5. So my c equals 16 over 5. So I'm going to get y equals negative 2 over 5x plus c. 16 over 5. Now the question says, leave it in the form ax plus by plus c equals 0. I'm going to multiply everything by 5. 5y equals negative 2x plus 16. And then I'm going to move it all to the left-hand side. 5y plus 2x minus 16 equals 0. Okay, question 2. A tree was planted. Exactly 3 years after it was planted, the height of the tree was 2. Exactly 5 years after it was planted, the height of the tree was 2.4. Given that the height, h meters of the tree, t years after it was planted, can be modelled by the equation. P and Q are constants. Find 3 significant figures where necessary, the value of P and Q. So we're going to substitute in what we know. So 3 years after it was planted, the height was 2 meters. So that must mean 2 cubed equals P lots of 3 squared plus Q. And that 2.4 cubed equals P lots of 5 squared plus Q. I'm now going to have some simultaneous equations. Okay? I'm then going to be able to work out my P and Q, and it's already told us that we need 3 significant figures. So, 8 equals 9p plus q, and we're going to have, I don't know what 2.4 cubed is. 2.4 cubed.
It's 13.824.
Yep, 13.824 equals 25p plus q. So I am going to take them away from each other. I'm going to do 1 take away 2. So this minus 8 equals, so 5.824 equals 25 minus 9, which is 16. 16p. So if I divide 0.364, perfect.
Yeah.
I'm glad we're getting the same. Okay, so now I'm going to substitute that back into this one, into number 2 to get q. So 0.364 times 9, and then 8 minus the answer gives me 4.724. So q is 4.724. Brilliant. I can now rewrite this as h cubed equals 0.364 t squared plus 4.724. It then says, exactly 2 years after the tree was planted, the height was 5 meters. Find the value of t according to the model, given your answer to 1 decimal place. Okay, so this time we're trying to find what t is. So for part B, we know that 5 cubed must equal 0.364 t squared plus 4.724. So I'm going to do 5 cubed minus 4.724, and then divide it by 0.364, and then square root it. So then I get t equals plus or minus, but we can't have a negative number of years. So it's going to be 18.177, which is 18.2 to 1 decimal place. Nice and simple. Okay, question 3. Okay, figure 1 shows a sketch of part of the curve with the equation y equals 4 cos x. And it wants us to state all the coordinates. So first of all, if you think about this, y equals 4 cos x, is it inside or outside the bracket? Outside. Who does it affect? Y. So that must mean that all of my y coordinates, we know this 1 and minus 1 is now 4. And negative 4. We know with cos that this is 180, this is 90, this is 360. So we know that every little bit goes up by 90 essentially. So state the coordinates of P. So P minus 90 minus 180 minus 4. So minus 180 minus 4. For Q, this is 360. Another one plus 90 is 450. So that's 450 and my height is 0. Then says the curve C2 has equation y equals 4 cos of x plus k, where k is a constant. Now this k is on the outside, so it affects y. So it means we're shifting. We're moving it up or down. It's a translation. The curve C2 has a minimum value of y of minus 1. Okay? So the point R is the maximum, which is the smallest. State the coordinates of R. Okay, so my maximum with the smallest positive x coordinate. Okay, so this is my only maximum so far here, with the smallest possible x coordinate, because here it's 0, okay? So here, for it to be positive, we're going to have, it is going to be 360, we know that. Okay, so if it's minus 1, if this is minus 4 and it's shifted up to minus 1, what we've done is we've moved it up 3, so my k must be 3. So that means if this is 4, we add 3, we're going to get 7. So nice and easy, 5 marks really. Okay, question 4. So the points P and Q are shown in the figure. They have coordinates minus 2, 13. I'll write it on there. And 4, minus 5, respectively. Find an equation for the line that passes through both of them. Okay, so find the gradient first, which is the difference in y over the difference in x. So minus 5 minus 13 over 4 minus 2. So I'm going to negative 18 over 6, which is negative 3. And then I can choose any point. I'm just going to choose minus 2, 13. So I'm going to have 13 equals minus 2, sorry, done that the wrong way, gradient. Minus 3 lots of minus 2 plus c. So 13 equals 6 plus c, so c equals 7. So we're going to get y equals negative 3x plus 7. Okay, and if I think about that, that does make sense. I should have a negative gradient here. It is steep, so it should be higher than, not higher than minus 1. What I mean is, well, lower than minus 1 technically. But if the gradient was 1, it should be bigger, not smaller than. It shouldn't be a fraction, as in like less than 1. Then our plus 7, if you think this is 13 here, and this is 0, I know they're not drawn accurately, but of course it crosses, we can see it crosses here. So 7 is good. Then it says a quadratic curve passes through the point P and has a minimum point Q. Find an equation for C. So this time we're given the minimum and it passes through here. Okay, so if I'm given the minimum, how do I find the minimum? Completed square form. So we know that x minus 4 squared plus 5 is the equation. However, if we're saying y equals this, I'm going to substitute in this because even though I've gone backwards, sometimes we don't know. There could be an extra 2 out here. We don't know if this was a stretch in the y because it just doesn't show up if we use this method. If we put it back into the bracket, we don't know. There could be a number here. So we're going to test our theory of putting in 13 and negative 2. So 13 equals minus 2 lots of minus 4 squared plus 5. Let's see if that's true. Minus 2 minus 4 is negative 6 squared. Negative 6 squared is 36 plus 5 is 41. I get 13 equals 41. Okay, that doesn't seem right, does it? No. So we know there's clearly something wrong. Okay, so 13 equals 41 is not correct. However, 41 divided by what is 13?
3.1 something.
Yeah, which doesn't seem right either. Guys, sorry, a little bit of a mistake here. This is negative 5, this should be negative 5. Okay, that's fine. Doesn't matter if we go wrong, as long as we spot where we've gone wrong. So this should be negative 5, this should be negative 5. So 36 minus 5 is 31. Is that right? Yeah, it's 31, isn't it? Okay, 31 divided by what is 13?
31 divided by 2.3 something.
Yeah, that still doesn't seem right either. Sorry, I know where we're going wrong. So, what we have to remember is, we're saying, sorry, I've been very silly here. We're saying there could be an A here then, essentially, that we need to figure out. So what we need to do is add 5 to both sides first. So we're going to get 18 equals A lots of minus 6 squared. So 18 equals 36A. So A must equal 18 divided by 36, which is a half. Okay? Because remember, with this bit here, we need to go backwards. So that must mean that our equation of the C is a half of x minus 4 squared minus 5. Okay? Okay, sorry, I did make a mistake there, but it's okay. It's really good to make sure that we copy down the right things. It's so easy to make, but at least you know if it's not making sense, you've gone wrong. Right then, so now we have the equation here. And then it says the region R shown, shaded in figure 2 lies in the second quadrant is bounded by C and L only. Use inequalities. Okay, so first of all, we know that it's above the line because here is my straight line and it's above that. So we know for the first one, once we have our straight line, it's greater than. So y is greater than minus 3x plus 7. That would lead us to shade that region. Okay? Then for the next one, what else do we know? We know that we have the curve here and it's below the curve. Okay? It's below, like this side and around here. It's not inside the curve. So that means it is less than. So y is less than a half x minus 4 squared minus 5. Okay? Yep. And what we notice as well is that if we were more than that line, we'd be over here as well. Okay, it would shade this region too. And if we were less than the curve, we'd also be here as well. And clearly, we're not. We're just in this part here. So that must mean that x must be also less than 2. Negative 2, sorry. This coordinate here. And then as well, the lines are solid. So we're going to have less than or equal to for all of them. And if they were dotted, we wouldn't include them in there. Okay? However you do it though, in the mark scheme, it will allow you if you just put less than or greater than, but you have to be consistent. They're either all less than or equal to, or they're all just less than or greater than, okay? Okay, question 5. Now they always have these types of questions, and normally it's always a logo in some weird shape. Okay, so here we go. Figure 3 shows the plan view of a viewing platform at a tourist site. The shape of the viewing platform consists of a sector and a circle. Okay, so OA is OC, which is 6. So that is the radius. So the radius is 6. AD is 14. ADC is here. That's 0.43 radians. And before I carry on with the question, I'm going to put my calculator into radians. And it is. Angle AOD is an obtuse angle. So AOD is obtuse. What does obtuse mean?
Greater than 90 degrees.
Yeah, greater than 90 degrees and less than 180. Okay, so we know obtuse is in between 90 and 180. However, we're in radians. So what does this mean? It means it's in between pi and pi over 2, which is, just to make my life easier, so this is 3.14, and this is like 1.6, okay? And then it says OCD is a straight line, OCD, perfect, okay? So that just helps us. It then says, find the size of the angle AOD, okay? So we need to find this angle here, AOD. Okay, so I would normally use cosine. However, I do not have this length here. So what I'm going to do is, that is opposite to that and that is opposite to that. I'm just going to use sine rule. Yeah, because 6 is opposite to this angle and this is opposite to 14. So I can use sine rule. So sine of x over 14 equals the sine of 0.43 over 6. So sine of x equals 14 times sine of 0.43 all over 6. So I'm going to literally write that how it looks. Sine 0.43 over 6. Oh, and I forgot a bracket. Yeah. Okay, so I get sine of x equals 0.972 dot dot dot. X equals shift sine answer 1.33. Okay, what do I notice about my 1.33 value and the fact that it told me it was obtuse? Does that look like it's in between? Yeah, it's not in between this. So let's see what's going on. So I'm going to draw the sine graph. Okay. Oh, that's cos. Okay. Okay, so I know this is 180 or pi. Okay. Now, if I look at the sine graph, this is 0.972. So if my maximum is 1, 0.972 is like around here. If I go across, I've clearly got this answer and I want this one. So using symmetrical properties, I'm going to do pi minus 1.3365. And this is going to give me the obtuse angle, which is also the same. So shift pi minus answer, I now get 1.805 to 3 decimal places, 0, 0. So my angle in radians is 1.805. And now you can see I know it's definitely obtuse. 1.805. Perfect. And also, from the sine graph, I know that this is 90, 180. So it has to be, my answer that I'm looking for is in between these two, because it has to be obtuse. Okay then. It then says the length of the arc ABC in meters to 1 decimal place. So ABC, here we have it, the length of this. Okay, so first of all, I know that this angle here is 2 pi minus 1.805. And 4.478. And then arc length, I never remember the formula, but I know I'm going to have to do angle over 2 pi times 2 pi r. So it's just this times 6 then. It's just the angle times the radius. Thank you. So what do you get 26.868?
Yeah.
Perfect. 28.868 26.9 to 1 decimal place. Perfect. It then says, find the total area of the viewing platform in meters squared to 1 decimal place. So really nice and easy. I have two shapes. I have a major arc here, and I have a triangle. For the triangle, I'm going to do a half AB sine C. Okay. However, we didn't get this angle, but that's okay because I know angles in a triangle add up to 180. So I'm going to use this as my angle. So to make my life easier, I'm going to do pi, which I know is essentially 180, minus 1.805 minus 0.43. That's going to give me this angle here of 0.9065 dot, 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 dot. I'm going to leave it as an answer though. So a half times 6 times 14 times sine of that angle that we've just 0.9065 dot, dot, dot. But I've left it as answer in my calculator. So a half AB 6 times 14 times sine of the angle, answer. So the area of the triangle is 33.0711. And then the area of the arc, I know, is theta over 2 pi times pi r squared. Yeah. Theta over 2r squared. So the angle, 2 pi, 4.478 over 2 times 6 squared plus 33.0711. So 4.478 divided by 2 times 6 squared plus 33. 80.604. I got 113. Oh, yeah, because you've done just that part, yeah. So my total is 113.6751. 1 decimal place is 113.7 meters squared. Okay. Yeah, question 6. Sketch the curve of the equation y equals minus k over x. Okay.
Do we need to mention coordinates?
No, we won't. No, it doesn't say anything about coordinates, so I think we're okay for the first one. So for the first one, obviously I'm using a ruler. It's just if they're wonky, it must be something wrong with your screen. So 1 over x is this, isn't it? Minus that means a reflection on the x-axis. So reflecting the horizontal line, we're going to have this. Okay?
Yeah.
Then it says on a separate diagram, sketch the curve of the equation. Now this time it does say state the coordinates of the points of intersection with the x-axis in terms of k. Okay, so this time we need to actually see what's happening. So if this plus k is also outside the bracket, so all we're doing translation up. So we're moving it up this time. So I'm going to draw it here. So I'm going to draw it and essentially move it up by k. So, oh, that was terrible. And then, oh, no. There we go. Now remember, we're going to have this asymptote, aren't we? Whatever we moved it by, this is going to be our asymptote, y equals k. Okay? And it wants us to state in the coordinates of the points of intersection with the x-axis.
Yeah.
This one.
I got 1, 0.
1, 0.
Yeah.
How do you know it's 1, 0? I don't agree with that. So when does 0 equal minus k over x plus k? So k over x equals k. So k equals xk. X equals k over k, which is 1. So this one is 1, 0. Okay, perfect. Yeah, I do agree with that. Right then. Then part C. Find the range of possible values of k for which the curve of the equation does not touch or intersect the line with the equation y equals 3x plus 4. Okay, well, if I think about 3x plus 4, let's put the line here. No, I'm going to get my ruler, actually. We know 3x plus 4 is positive gradient, and it crosses at 4. Okay? So for it to have no solutions, ideally, we want it to be kind of where the asymptote is. Okay? But we want it to be like between here and here. So wherever the graph is, as long as that is in between. Now, if they do not intersect, it means they don't have any solutions. So when we equate them, we know that our b squared minus 4ac must be less than 0. So let's put them equal to each other. So 3x plus 4 equals minus k over x plus k. Okay? So if I move everything to the left-hand side, and then now I'm going to multiply everything by x because we have a hidden quadratic. So 3x squared plus 4x plus k minus kx equals 0. 3x squared plus, now here I've got 4x and minus kx, so I can factorize out x, 4 minus k, plus k. So now I've got my a, my b, and my c. So if they do not intersect, my discriminant is less than 0. So 4 minus k squared minus 4 lots of a, which is 3 lots of c, which is k, is less than 0. So I'm going to get k squared
minus 20k plus 16.
Okay, minus 8k plus 16 minus 12k is less than 0. Yeah, you're right. So k squared minus 20k plus 16 is less than 0.
So k is plus 10 plus minus 2 root 21.
Oh, okay. So wait there. Okay, so when I solve this, I get k equals 10 plus or minus 2 root 21. Now, this is less than 0, and it's a positive, so that means we have one inequality. So we have 10 minus 2 root 21 is less than k, which is less than 10 plus 2 root 21. Brilliant, and there we have it. Nice 5 marks. 7. So here we have the equation. We want to solve it equal to 9. So step 1, I need to put it in index form. So so I'm going to have 2x minus 3x to the half minus 5 equals 9. Now I'm going to take away 9 from both sides. So 2x minus 3x to the half minus 5 minus 9 is minus 14 equals 0. Now I can see here I've got a hidden quadratic. So I'm going to let y equal x to the half. Yes. So I'm going to have 2y squared because I know that x is the same as x to the half squared. So it must be y squared minus 3y minus 14 equals 0. So when I solve this, what do I get, please?
7 over 2 and minus 2.
So I get y equals 7 over 2 and y equals minus 2. Now, remember we said that y was equal. So we're saying root x equals 7 over 2, or the square root of x equals negative 2. However, can a square root of a number give me a negative 2? No. So we reject this one. Square root of a number gives me 7 over 2, so now I square that to find my x, which is 49 over 4. Now I know I can square minus 2 to give me positive 4, but the point is that a root of a number would not give me negative 2. Okay? Then that's done. Part B then says solve the equation f double differentiated equals 6. Okay, so I have it in index form here. So I'm going to use that and differentiate to get 2 minus 3 over 2x, take away 1 from the power to the negative half, and minus 5 differentiates to 0. If I differentiate this again, I'm going to get positive 3 over 4, x to the negative 3 over 2. And now they're saying that this equals 6. So 3/4 x to the minus 3 over 2 equals 6. Okay, so I'm going to divide both sides by 3/4. So x to the negative 3 over 2 equals 8. Now, x to the negative 3 over 2. So there's a few different ways you can do this. If you want, you can square, so you know to get rid of the minus, it's 1 over. And then,
that's what I did.
yeah, and then you could do what to the power of 3 which is 1 over 8. So you could square both sides and then cube root it. You can do the opposite. 64 cube rooted is 4. So we have a quarter. X equals a quarter. So how are we going to get rid of this to the power, to a half? We square both sides and then cube root it. Okay? Okay, question 8. So we have a diagram, lots of words. Let's just get to it. Okay, so just get my colours. Right, it shows part of a sketch. The equation's 3x minus 2 squared x minus 4. Okay, so I know this coordinate is 4, 0. And I know that this coordinate is 2 over 3, 0, because this is my square. Deduce the values of x for which f of x is greater than 0. Well, where is the graph greater than 0? So where is it above this line? It's here, when x must be greater than 4. So x must be greater than 4, and then we'll have something above the line. Then it says expand f of x to the form. So we're just expanding this. Okay, so I'm going to expand 3x minus 2 squared first. So I'm going to get 9x squared minus 6 minus 12x plus 4. I'm now going to multiply that by x minus 4. So I like to multiply everything by x first. And then I multiply it by minus 4 and write it underneath. So minus 36x squared plus 48x minus 16. And then now it's easier to simplify. So I'm going to get 9x cubed minus 48x squared. Nope. Plus 52x minus 16. Brilliant.
Yeah.
It then done. Okay. Well, that's really easy. Right. Last part of the question then. The line L, also shown in figure 4, passes through the y-intercept of C and is parallel to the x-axis. Okay, here it is. So the line cuts C again at the points P and Q. Okay, yeah, so we know that this line is y equals negative 16 because that's my y-intercept, and it cuts here, here, and then here. So using algebra and showing your work, and find the length of the line PQ, write your answer in the form k root 3. Okay, so I need to find the coordinates of PQ first, and then I can use Pythagoras to find the length. So I know that this equals negative, so I need to put the equation equal to y equals negative 16. If I do that, I get 9x cubed minus 48x squared plus 52x minus 16 equals negative 16. They're going to cancel. So then I can factorize out an x, and
x equals 0, x equals 8 plus 2 root 3 over 3, and 8 minus 2 root 3 over 3.
okay, so x equals 0. And then when I solve this, I get x equals 8 plus or minus 2 root 3 over 3. Perfect. So then I have two things for x, which is nice. That's not a very nice number. However, pretty sure we've done everything right. Okay, well, let's just roll with it. So now I have two coordinates. How am I going to find the distance? Well, lucky for us, actually, we don't have to use Pythagoras because we actually know they're on a straight line. So if we find one, we just take it away from the other. Okay? So we're going to do 8 plus 2 root 3 over 3 minus 8 minus 2 root 3 over 3. And then, I mean, in the question it did actually say I wanted it in root 3, so I suppose there is a good sign. 8 plus root 3 over...
You'll get 4 root 3 over 3.
So 4 root 3 over 3, which is 4 over 3 root 3. K is a constant. Yeah, so K equals 4 over 3. And yeah, that looks about right. Oh, that wasn't too bad, actually. Just required some thinking. So well done.
The final question.
Yeah, it's the final question. So, part I, find the integral, given your answer in its simplest form. Okay, so for part I, index form first. So we're going to have 3x plus 2 squared, which is going to give me
9x squared plus 12x plus 4.
Yep, 9x squared plus 12x plus 4 over 4 root x. So that's over 4x to the half, over 4x to the half, over 4x to the half with respect to x. So then we're going to have the integral of 9 over 4x, and then 2 minus a half is 3 over 2. 12 over 4 is 3x, 1 minus a half is just a half, and then plus 1 over x to the half, which is x to the negative a half with respect to x. Now we have it in index form, we are able to integrate, and it's really important that we have an index form first. It will make our lives easier. Okay, so increase the power by 1, 5 over 2, and then divide by the new power. 9 over 4 divided by 5 over 2. It's 9 over 10. Then increase the power by 1, 3 over 2, divide by the new power. 3 divided by 3 over 2 is 2. Increase the power by 1, positive a half, divide by the new power, negative 2. And then we have to remember our favourite thing to write, plus c. Perfect. So there we go, nice and simple, 5 marks. Part II has nothing to do with I. Okay, that's fine. So a curve has the equation y equals f of x. Given that, okay, so if we differentiate it, we get quadratic. Okay, so dy by dx equals x squared plus ax plus b. Okay, this is like a murder mystery that we're going to solve now. The y-intercept of c is -8. Okay, so c equals -8. Brilliant. The point lies on C, and the gradient of C at P is 2. Okay, well, this is good news. Right, so the gradient of C at P is 2. And P is 3 minus 2. So we know that the gradient equals 2 when x equals 3. So we're going to have 3 squared plus 3x plus b. 3a, not x, 3a plus b. So I'm going to get 2 equals 9 plus 3a plus b. So that must mean -7 equals 3a plus b. Okay, we've used that one. That's good. Right, the next one. Actually, I'm not going to cross it out, Yep. Okay, let's integrate it. So if we integrate x squared plus ax plus b with respect to x, we're going to have x cubed over 3 plus a squared over 2 plus bx plus c, which told us it was -8. Okay, so y equals this. And then tells us that 3 minus 2 lies on the line. Okay, so we've used that one now. We've used that one. So if I substitute in 3 and -2, we should then get another equation with a and b in, and then we'll have simultaneous equations. 3 minus 2, yep. So -2 equals 3 cubed over 3 plus, sorry, that was ax squared. A lots of 3 squared over 2 plus b lots of 3 minus 8. Okay. Okay, yep. So -2 equals this. So that must mean that blah, blah, blah. -3 equals 9 over 2a plus 3b. Okay, brilliant. Right, we've now got 2 simultaneous equations. Did the question ask us to find a and b? Or are we just going off on a tangent? Yeah. No, it says find f of x in its simplest form. So once we find a and b, we'll be able to do this. Okay, so, right then. I'm going to have minus 3a minus 7 equals b and substitute that in. You do it a different way and then let's see if we both get the right answer. So minus 3 over 9 over 2a plus 3 lots of negative 3a minus 7. Is that 18? A equals minus 1. Okay, I'm nearly there.
Minus 4.
Oh, minus 4. Okay. Minus 9 over 2a. 18 divided by that. Yep, I got a equals negative 4. So that must mean that b equals minus
5.
12 minus 7, which is 5. Yep. Perfect. Okay, this is great news. So then my final equation must be y equals x cubed over 3 plus a x squared over 2. So minus 4 over 2 is negative 2x squared plus bx, so that's fine, plus 5x minus 8.
Yeah.
Perfect. Oh, wow. Haven't seen one of those questions before. That was really good. Okay. So that is the end of the paper. Well done and thank you.